channel. This is Decagon Math. In today's video, we'll be solving the problem on exactness of an homogeneous equation. In my previous video, I have shown us the type of equation, or the general form of an equation that we'll be told to find the exactness. And also, I have given us the conditions for which a homogeneous equation will be exact. So if you have not watched that video, I will leave the link in the description so that you can watch and have a full understanding of what we are doing. In the previous video, I also solved a problem. That was our first problem, right? On exactness of an homogeneous equation. Now in this video, I will be solving another problem on determining the exactness of an homogeneous equation. So this problem too, we have to verify whether 2x cos y plus 3x squared y dx plus x raised to power 3 minus x squared sin y dy equals to 0. Now the solution. Now the first thing that we are going to determine our m, right? Now in this case, our m is always the one with dx, right? Is equals to 2x cos y plus 3x squared y. Now, and our n is equals to x raised to power 3 minus x squared sin y. It's always the one with dy. Alright, the next thing is to find the partial derivative of m with respect to y. That means we are going to find partial derivative of m with respect to y, which equals to the partial derivative of 2x cos y plus 3x squared y with respect to y. Right? Now we know that this thing can also be written as this equals to the partial derivative of 2x cos y with respect to y plus the partial derivative of 3x squared y with respect to y. Right? Now, and I've explained in the previous video that since we are finding the partial derivative with respect to y, that means we are taking anything that has to do with x, we are taking them as constants, right? That means in this 2x cos y, 2x is a constant, right? So we can write it like this: 2x, then partial derivative of cos y with respect to what? With respect to y, plus we have also 3x squared here will also be taken as constant, right? So we have 3x squared, then partial derivative of y. We are just left with y here, right? With respect to y. Alright. Now, when we differentiate partially cos y, when we differentiate cos y, when we differentiate cos y, we get minus sin y. That means we have 2x into bracket minus sin y, then plus. Now when we differentiate y, it gives us 1, right? So we have 3x squared multiplied by 1, that is just 3x squared. Now this gives minus 2x sin y plus 3x squared. Now so these are the partial derivative of m with respect to y. So the next thing we are going to do is to find the partial derivative of n with respect to x. That means we have partial derivative of n with respect to x will equal to, that is x raised to power 3 minus x squared sin y over this. Also this we can also split it, right? And we can write it as the partial derivative of x cubed over the derivative of x minus the partial derivative of x squared sin y over this. Alright, now since you are taking the partial derivative with respect to x, that means any terms of y will be taken as constants, right? Now, considering this first one, we don't have any y here, so we leave it like this. Why this one? We bring out the sin y because it's a constant. So we can write this as this. So sin y comes out, and we place this. Alright, I need space, okay. Let me work with the space here. Sorry. All right. All right now. So let's continue from there. So that is the partial derivative of n with respect to x continues, and we have when we differentiate x raised to power 3 now, it becomes 3x squared, right? So this becomes 3x squared. And also, when we differentiate x squared, we have 2x. So we have minus sine y multiplied by 2x. Now this gives 3x squared minus 2x sine y. Now let's check um, our answer here. What do we have here? Now this is minus 2 sine y plus 3x squared. That is our partial derivative of m with respect to y. Now the next thing we are going to do is we are going to compare the partial derivative of n with respect to x to partial derivative of n with respect to y, right? So now let's write them out. We obtain that partial derivative of n with respect to x is equal to 3x squared minus 2x sine y. Y is the partial derivative of n with respect to y. We obtain minus 2x sine y plus 3x squared. Now, it's actually writing it out now doesn't look the same, but when you check it, this is minus 2x sine y minus 2x sine y, and this is 3x squared, and this is also 3 plus 3x squared. So we can see that they are the same. Definitely, we can now write that our partial derivative of m with respect to y is equal to the partial derivative of n with respect to x. As you can see, right? Since they are equal. So that means, and this is the condition for our equation to be exact. Now, since we have it like this, right? Definitely, the equation is exact. So we write that the equation is exact, and this will be our conclusion. That means the equation given is exact because it satisfies the condition that has been given for the equation to be exact, right? So we have come to the end of this video. Thank you for staying through. If you like what you have seen, kindly subscribe to my channel and also comment, like, and share this video. So see you in the next video. Goodbye.